Welcome everyone to today's Explainer. We're diving into a really fascinating scientific phenomenon today, one that, well, literally follows us everywhere we go. We're exploring the world of light and shadows. And as a bonus, we're actually building our scientific vocabulary bilingually today. So we'll be learning the Myanmar term, alin nit idiot nya, right alongside the English. It's going to be an illuminating journey, so let's get right into it. Think about this for a second. Have you ever wondered why your shadow suddenly grows into this towering giant when you walk past a street lamp at night, but then completely vanishes the second you step behind a clear glass window? It's something we see every single day, right? But the underlying science here is exactly how we understand the way light travels and interacts with our physical world. Okay, here's our game plan for today. 5 quick sections. First, light and shadows. Second, how shadows are made. Third, changing shadow sizes. Fourth, transparent materials. And finally, Section 5, translucent materials. Let's kick things right off with Section 1, light and shadows, or alin and adipnya. Before we get into all the cool stuff about how shadows stretch and shrink, we need to nail down our basic glossary. So let's start with the most important definition of all. A shadow, or aremia, is basically just a dark area that's made when light is blocked. That's it. Whether you're learning this in English or Myanmar, the scientific truth is identical. A shadow isn't an actual physical object, it's literally just the absence of light. It's a dark patch that only exists because something stubbornly got in the way of a light beam. Which brings us neatly to Section 2, how shadows are made, or ayetmya pyutbaubonne alimbay pisimya. What exactly has to get in the way of the light to create that dark patch? Imagine a kid standing directly between two really bright street lamps. If you trace the paths of light beaming down, you see something super cool. Because her body blocks the light coming from the left lamp, boom, a shadow forms on the right side. And because she's also blocking the light from the right lamp, a second shadow pops up on the left. Two light sources being blocked means two entirely distinct shadows. It is a perfect, everyday example of cause and effect in physics. Now, the reason we cast shadows at all is because human beings are opaque. Opaque, or alinpit pisimyan, refers to materials that light just absolutely cannot pass through. Think of that really thick cardboard you might use to make shadow puppets. When you hold an opaque puppet up to a bright light, the light just stops dead in its tracks. It can't go through the card, so it leaves this crisp, dark silhouette on the wall behind it. So, if you want a punchy summary to remember, here is the golden rule of making a shadow. Light is blocked equals dark area is made. If a material is opaque, the light stops and a shadow is born. It's an unbroken rule of physics. But here's the thing, shadows have some really quirky characteristics. Because they are literally just messing light, shadows have zero color. They are always dark. Plus, they don't have any internal details. You could be wearing the brightest, craziest patterned shirt, giving a huge smile, but your shadow isn't going to show your eyes, your mouth, or your clothes. And on top of that, a shadow might not even be the same shape or size as the object casting it. It can stretch way out or shrink way down. Let's look at exactly how that shrinking and stretching works in Section 3, Changing Shadow Sizes, or ayetmya eguesanet pondetaun pian lepom. We have a bit of a data mystery to solve here. Let's check out some experiment data from a student named Marcus. He measured how a shadow's size changed as he moved an object around. In his first test, the object was 50 centimeters away from the light, and the shadow was just a tiny 6 centimeters wide. But as he moved it closer, 40 centimeters, 30, 20, look at what happens to the shadow. It shoots up from 14 to 25 to 34 centimeters. You're probably spotting the pattern already, right? The real giveaway is this final number right here, 42. In his fifth test, the shadow hit its absolute maximum size, a massive 42 centimeters. And when did that happen? Precisely when the object was at its closest distance, just 10 centimeters away from the light. So the data gives us a super clear conclusion here. As an object moves towards a light source, its shadow gets bigger. Just think about making hand puppets against the wall with a flashlight. The closer you bring your hand right up to the bulb, the more massive that shadow dog gets. Why? Because your hand is blocking a much wider angle of that light beam. Okay, but what if the light isn't blocked? That brings us to Section 4, Transparent Materials, or alimpyatan naida piesimya. This is basically the big exception to our opaque rule. So here's our working definition. Transparent, or alimpyatan naindo piesimya, describes materials that let light pass straight through them perfectly clearly. And because that light travels straight through without being interrupted, transparent materials do not make a shadow at all. And you can see why this is absolutely crucial in the real world. Think about scuba goggles for a second. The diver obviously needs the physical glass to keep the water out of their eyes, but they critically need the light to pass right through so they can actually see the coral reef. Or how about those massive, terrifying glass bridges suspended over canyons? They easily support the physical weight of the tourists, but because they are transparent, the light passes straight through, giving everyone a crystal clear, dizzying view of the drop below. The big takeaway here is utility. Transparent materials protect us physically while still letting us see clearly. Whether it's your car windshield blocking a 60-mile-an-hour wind or the lenses in your eyeglasses helping you read the screen, they offer a physical barrier without creating a visual one. All right, so we've seen opaque, which blocks everything. We've seen transparent, which lets everything through. Now, let's explore that really cool middle ground in our final section, translucent materials. Or alin tuwet yong piat den nine tho pisimiatnit and alin piat luin pong. Let's do a quick side-by-side. With a transparent material, the light passes straight through like an arrow hitting a target, so we see things perfectly clearly on the other side. But with a translucent material, the light enters, but it gets scattered in a million different directions. Some of the light definitely gets through, but because the path is all disrupted and chaotic, things on the other side do not look clear at all. They look super blurry and out of focus. So our formal definition for translucent, or a lan pian limpong, is simply materials that scatter light, making it really hard to see or read through them. A classic, everyday example is frosted glass. If you tried to read a book through a pane of frosted glass, the letters would just be this fuzzy, scattered, unreadable mess. So why do we even use this stuff? Well, translucent glass is an absolute game changer for privacy. Think about bathroom windows or shower doors. You want the sunlight to get in so you aren't showering in the pitch dark. But because it scatters the light, nobody outside can actually see clearly through it. Plus, because translucent materials intercept and scatter light, you can actually cast really beautiful, soft shadows onto them, which makes them super popular in architecture and home design. Well, that brings us to the end of our journey today. But I want to leave you with a quick little challenge to test out your newly upgraded bilingual scientific knowledge. Take a look around whatever room you are in right this second. Can you spot one opaque object that completely blocks light, one transparent object that lets it sail straight through, and one translucent object that scatters it? Have a look. Thank you so much for joining me on this explainer. Keep observing the amazing science happening right in front of your eyes every single day.